To understand the fragility of existence, one must first discard the illusion of solid ground. We navigate our lives with an implicit trust in the consistency of the universe. We assume that the chair beneath us will remain composed of atoms, that the sun will continue its nuclear dance, and that the vacuum of space, the vast silent nothing between the stars, is exactly that, empty, stable, and inert. But modern physics suggests a terrifying alternative. What if the very foundation of our reality is built upon a cosmic mistake? What if the emptiness of the universe is not actually empty, but is instead a high-energy, false floor suspended over a much deeper, much darker abyss? In the language of quantum field theory, this is the nightmare of the false vacuum. To understand it, we must look at the most important nothing in existence, the Higgs field, the invisible architect. Imagine the universe not as a collection of objects, but as a series of invisible layers or fields that permeate everything. There is an electromagnetic field, a gravitational field, and, crucially, the Higgs field. This field is the invisible architect of the cosmos. Without it, particles would have no mass. They would zip through the universe at the speed of light, unable to form atoms, stars, or DNA. Most fields in nature prefer to be at their lowest possible energy state. Think of a ball sitting at the bottom of a valley. Gravity wants that ball to stay in the lowest spot because that is where it is most stable. In physics, we call this the ground state. For decades, scientists assumed that the Higgs field was already in its ground state, that it had reached the bottom of its valley and was resting comfortably. However, as we measured the mass of the Higgs boson and the top quark, the mathematical shape of this valley began to change. The data started to suggest something unsettling. Our universe might not be at the bottom of the valley. Instead, we might be sitting in a small dip or ledge halfway up a much larger mountain. This state is what physicists call metastability. We are stable for now, but we are not in the most stable state possible. We are living on a false floor, the phenomenon of metastability. To visualize metastability, imagine a forest during a dry summer. The forest looks peaceful. The trees are standing, the animals are moving, and the ecosystem is functioning. But the forest is metastable. It contains a massive amount of stored chemical energy in the form of dry wood. All it takes is a single spark, one lightning strike, to trigger a phase transition that turns the entire forest into ash. The universe is that dry forest. The true vacuum is the state of lowest possible energy. In that state, the Higgs field would be much stronger, or perhaps fundamentally different. If our current vacuum, the false vacuum, is the dry forest, the true vacuum is the pile of ash. The transition from one to the other is not a gradual change. It is a violent, catastrophic collapse of the laws of physics themselves. Why the false floor matters. You might wonder why a change in an invisible field matters to your daily life. The answer is everything. The properties of the Higgs field determine the fundamental constants of nature. They dictate how strong gravity is, how atoms bind together, and how light behaves. If the Higgs field were to fall from its current ledge into the true vacuum, the floor of reality would vanish. In a true vacuum state, atoms could dissolve. The balance of forces that keeps electrons orbiting nuclei could vanish. Chemistry would cease. Molecular bonds would become impossible. The vacuum itself would become heavy. space could become so dense with energy that it would instantly collapse into black holes. We exist only because the Higgs field is stuck on this ledge. We are the beneficiaries of a cosmic delay. But in the quantum world, nothing stays stuck forever. The razor's edge of physics. The most haunting part of this theory is how close we are to the edge. When physicists plotted the mass of the Higgs boson, roughly 125 giga-electron volts, against the mass of the top quark, roughly 173 giga-electron volts, they found that the universe sits almost exactly on the boundary between stability and instability. If the Higgs were slightly lighter, the universe would have collapsed billions of years ago. If it were slightly heavier, we would be in a true vacuum and perfectly safe. Instead, we are in the marginally stable zone. We are living in a reality that is good enough to last for billions of years, but bad enough that it could technically end at any moment. This is the false floor of reality. We look up at the stars and see a vast, ancient, and permanent structure. But the math tells a different story. It tells us that the vacuum of space is a pressurized container held shut by a barrier that is thinner than we ever imagined. The cosmic mistake. There is a philosophical dread that accompanies this realization. If the universe is in a false vacuum, it means the Big Bang didn't quite finish the job. It means the birth of our universe was a partial cooling, a phase transition that got caught on a snag. We are the inhabitants of that snag. Our entire history, from the first spark of life in the primordial oceans to the greatest achievements of human civilization, has taken place within this temporary bubble of false stability. We are like characters in a play performed on a stage that was never meant to be permanent. Below the floorboards, there is a basement of infinite energy waiting for the floor to give way. The microsecond threat, the title of this paradox, mentions a microsecond for a reason. Unlike a star-going supernova or a galaxy colliding, which are slow, majestic events, vacuum decay is a binary event. It is an on-off switch for existence. As we will explore in the coming chapters, if a spark ever occurs, if the Higgs field ever manages to tunnel through the barrier holding it on that ledge, the transition happens instantly. The false floor doesn't crack, it vanishes. The energy released by the collapse would create a bubble of true vacuum that expands at the speed of light. Because it travels at the speed of light, you cannot see it coming. There is no warning. There is no telescope that can spot the wall of the bubble before it hits us. In the time it takes for a neuron in your brain to fire, a mere microsecond, the universe, as you know it, would be overwritten. Conclusion: the comfort of the ledge. It is tempting to feel a sense of impending doom when contemplating the false floor. However, there is a strange beauty in it. The fact that the universe is metastable means that we exist in a very specific, a very delicate window of cosmic history. We are the witnesses to a false reality that is complex enough to allow for consciousness, art, and love. The true vacuum might be more stable, but it would likely be a barren, featureless void where no two particles could ever meet. We live on the ledge. It is precarious, it is temporary, and it is technically impossible by the standards of total cosmic equilibrium. But for now, the floor is holding. In the first chapter, we established that our universe sits on a false floor, a metastable ledge in the energy landscape of the Higgs field. But if we are on a ledge, why haven't we fallen off yet? In the world of classical physics, the physics of rolling balls and swinging pendulums, a system stays put unless it is given a literal push over the edge. To collapse our vacuum, you would theoretically need to inject a staggering amount of energy into a single point in space to kick the Higgs field over the energy barrier and into the true valley below. However, we do not live in a classical universe. We live in a quantum one. And in the quantum realm, there is a phenomenon that defies every intuition of human logic. It is a process that allows a particle to pass through a wall without breaking it, to move from point A to point B without crossing the space in between, and to bypass a mountain without climbing it. This is quantum tunneling, and it is the invisible finger resting on the self-destruct trigger of the cosmos, the wall that isn't there. To understand the trigger, we must first look at how particles behave at the smallest scales. In our everyday experience, if you throw a tennis ball at a brick wall, it bounces back. It doesn't matter if you throw it once or 1,000,000,000 times. Unless you throw it hard enough to shatter the bricks, the ball stays on your side of the barrier. The wall is an absolute energy barrier. In quantum mechanics, however, particles like electrons or the Higgs boson do not have a single definite position. Instead, they exist as wave functions, clouds of probability. When a quantum particle encounters an energy barrier, the mountain separating our false vacuum from the true vacuum, its probability wave doesn't just stop at the surface. A tiny, infinitesimal portion of that wave actually bleeds through the barrier and exists on the other side. This means there is a non-zero mathematical chance that a particle will simply appear on the other side of the wall. It doesn't climb the hill. It tunnels through the base. This isn't a glitch in our math. It is a fundamental property of the universe. In fact, you wouldn't be alive without it. Quantum tunneling is the reason the sun shines. Hydrogen atoms in the solar core don't actually have enough heat to overcome their mutual repulsion and fuse, but they tunnel through the electrical barrier anyway, sparking the nuclear fusion that powers our world. But while tunneling gives us life via the sun, it also threatens to take everything away via the Higgs field. The Higgs field's secret escape, recall the energy diagram of the Higgs field. On one side is the false vacuum where we live, a shallow dip in the landscape. On the other side is the true vacuum, the absolute bottom. Between them is a massive hump of energy, a barrier so high that no natural process in the current universe should be able to push us over it. But the Higgs field is a quantum field. It is subject to the same laws of probability as an electron. At every single point in the observable universe, every cubic centimeter of empty space, every atom in your body, every star in the furthest galaxy, the Higgs field is testing that barrier. Mathematically, there is a constant, ongoing calculation being performed by reality itself. The field is essentially feeling out the thickness of the wall. Because of quantum fluctuations, the energy level of the field isn't a flat line. It's a vibrating, jittering mess. Every so often, one of those jitters is significant enough that a small patch of space might tunnel through the barrier. If this happens, the Higgs field at that specific coordinate snaps to the lower energy state of the true vacuum. It becomes a tiny subatomic seed of a new reality. The nucleation point, the spark in the dark The moment a single point in space tunnels into the true vacuum, it creates what physicists call a nucleation point. Think of a pot of superheated water. If you heat distilled water in a microwave in a perfectly smooth container, it can actually rise above the boiling point without turning into steam. It is metastable. It's trapped in a liquid state, even though it wants to be a gas. But the moment you drop a single grain of sugar or a spoon into that water, you provide a nucleation point. The water instantly and violently flashes into steam, exploding out of the cup. In our universe, quantum tunneling is the grain of sugar. Once that tiny bubble of true vacuum is formed, it is lower in energy than the space surrounding it. Nature abhors an energy gradient. The high-energy false vacuum immediately tries to flow into the low-energy true vacuum bubble. This causes the bubble to expand, and because the energy difference is so vast, the expansion accelerates almost instantly to the speed of light. This is the vacuum decay bubble. It is a sphere of altered physics, a shell of pure destruction that grows at 299,792,458 meters per second. The statistical gamble. Why are we still here? If quantum tunneling is happening everywhere, all the time, why hasn't a bubble started yet? Why have we enjoyed 13.8 billion years of stability? The answer lies in the sheer scale of the odds. While the probability of the Higgs Field tunneling at any one point is not zero, it is unfathomably small. Physicists have tried to calculate the half-life of our vacuum. The numbers they come up with are staggering, something in the neighborhood of 10 to the power of 100 years, a Google years. For context, the universe is only about 1.3 times 10 to the power of 10 years old. On a human timescale, the odds of a tunneling event happening in your neighborhood today are effectively zero. It's like winning the lottery every day for 1,000,000 years. However, there is a catch. The universe is incredibly large. If the universe is infinite, as many cosmological models suggest, then an infinitesimal chance becomes an absolute certainty somewhere in the distance. In an infinite cosmos, a vacuum decay bubble has likely already started somewhere. It might be millions of light years away, a silent, invisible wall of non-existence racing toward us through the dark. The artificial trigger, could we do it ourselves? There is a darker side to the tunneling paradox. Could intelligence, human or otherwise, accidentally provide the push that tunneling hasn't managed yet? When the Large Hadron Collider, LHC, at CERN was first activated, there was a fringe panic that it might create a black hole or trigger vacuum decay. The scientific community correctly dismissed this. Cosmic rays hit our atmosphere with energies millions of times higher than anything the LHC can produce, and they haven't triggered a collapse in 4 billion years. But as we look toward the future of ultra-high energy physics, particle accelerators the size of solar systems, or experiments involving the manipulation of Planck scale energies, the question becomes more pressing. If we ever reach the energy levels required to thin the wall of the energy barrier, we might inadvertently increase the probability of tunneling in a localized area. We would be, in effect, leaning against the door to see if it's locked, only to find that our mere presence has caused the hinges to snap. The Existential Ghost, Chapter 2, leaves us with a haunting realization. We are not held in place by a solid, unbreakable law of nature. We are held in place by a statistical probability. We are walking on a frozen lake. We know the ice is thick enough to hold us for now, but we also know that underneath the ice is a freezing, crushing depth. Quantum tunneling is the crack that could form at any moment, for no reason at all, starting from a microscopic flaw in the ice and spreading until the entire surface vanishes. The trigger doesn't need a hand to pull it. It doesn't need a why. It is a mathematical inevitability lurking in the very fabric of the vacuum. And as we will see in the next chapter, once that trigger is pulled, the transition is not just a change in state. It is a total, irreversible rewrite of the definition of something. If Chapter 1 was the foundation of the house, and Chapter 2 was the spark in the basement, Chapter 3 is the moment the walls vanish. To understand the bubble of nothingness, one must first abandon the cinematic trope of a space explosion. In a Hollywood movie, a planet exploding is a spectacle of fire, debris, and sound. But vacuum decay is not an explosion of matter. It is an explosion of physics. It is a structural failure of the vacuum itself. When the quantum tunneling trigger is pulled, a microscopic sphere of true vacuum is born. This is the bubble. It is a region where the Higgs field has settled into its true, lowest energy state. But because our current universe is overpressurized with the energy of the false vacuum, this bubble cannot remain small. It is a localized hole in the fabric of reality, and the universe rushes to fall into it. The anatomy of the wall. The boundary of this bubble is known as the phase front. Imagine a wall of energy thinner than a proton, but packed with more power than a supernova. This wall is the interface between two incompatible versions of reality. On the outside of the wall, the laws of physics are as we know them. Electrons orbit nuclei. Light travels at its constant speed, and gravity holds galaxies together. On the inside of the wall, those rules are overwritten. The expansion of this wall is driven by the energy difference between the two states. Because the false vacuum is at a higher energy level than the true vacuum, the transition releases a staggering amount of latent energy comparable to the energy densities of the Big Bang. This pressure pushes the wall outward. Within a fraction of a second, the bubble accelerates. It doesn't move at the speed of a bullet or a rocket. It accelerates until it hits the universal speed limit, c, the speed of light. This creates the ultimate cosmic paradox. The bubble is a physical object, yet it is invisible. Because it moves at the speed of light, the light reflecting off the front of the bubble can never reach your eyes before the bubble itself does. You cannot see it coming from a distance. There is no approaching wall of light. The moment you see the bubble is the exact microsecond your atoms cease to exist. The destruction of the particle standard. What actually happens when the wall passes through you? To understand the horror, we have to look at the standard model of physics. In our false reality, the Higgs field has a specific value that grants mass to elementary particles. This value is like the operating system of the universe. When the bubble wall passes through a volume of space, it updates the operating system to a version that is incompatible with life. As the Higgs field shifts to its true vacuum value, the fundamental constants of nature shift with it. Mass liquidation. In many models of vacuum decay, the particles that make up your body, protons, neutrons, and electrons, would suddenly have their masses altered. If the Higgs field becomes significantly stronger or weaker, electrons might no longer be able to stay in orbit around nuclei, the dissolution of matter. Imagine every atom in your body suddenly becoming untethered. The electromagnetic force that holds your DNA together, the strong nuclear force that keeps your heart beating, they are all calibrated to the current vacuum. Inside the bubble, these forces could change their strength. Matter would not just break, it would dissolve into a plasma of unrecognizable, massless fluctuations. The gravitational collapse. The energy released at the surface of the bubble is so intense that the vacuum inside might actually become gravitationally repulsive or infinitely attractive. In some theories, the interior of the bubble undergoes an immediate gravitational collapse, turning the entire contents of the bubble into a singular point of infinite density. Inside the bubble, there is no nothingness in the way we think of a void. It is a nothingness because nothing we recognize as something can survive there. The silent executioner, a microsecond of peace. The most terrifying aspect of the bubble of nothingness is its mercy. In every other disaster, a nuclear blast, a black hole's tidal forces, a viral pandemic, there is a window of realization. There is a moment where the victim understands that the end has arrived. Vacuum decay offers no such window. Because the transition occurs at the speed of light, the electrical signals in your brain, the very pulses that allow you to feel pain or process a thought, cannot outrun the wall. Your nervous system operates at a fraction of the speed of light. By the time your brain could even begin to register a change in the environment, the neurons themselves have already been rewritten into a different form of matter. If a bubble of true vacuum were to nucleate in the center of the Earth right now, you would not feel a tremor. You would not see a flash. You would simply stop. 1 microsecond, you are a conscious being pondering the mysteries of the cosmos. The next, you are a collection of unrecognizable energy states inside a bubble that is already claiming the moon, then Mars, then the sun. The sun would be extinguished not by a loss of fuel, but by a change in the laws of nuclear fusion. It would go dark the instant the wall hit it, but no one on Earth would ever know, because Earth would have already been deleted 8 minutes prior. The cosmic sweep, as the bubble expands, it grows into a macroscopic monster. Within hours, it would consume our entire solar system. Within 4 years, it would reach Proxima Centauri. Within 100,000 years, the entire Milky Way galaxy, with its hundreds of billions of stars and potentially trillions of planets, would be replaced by the true vacuum. From the perspective of an outside observer, if one could exist in a distant galaxy, the Milky Way wouldn't explode. It would simply vanish. One by one, the stars would wink out as the invisible wall of the bubble passed through them. It would look like a dark curtain being drawn across the sky. However, even this outside observer is not safe. Because the expansion is relentless and reaches light speed, the bubble eventually consumes everything in the observable universe. The only things that might survive are galaxies that are already moving away from us faster than the speed of light due to the expansion of the universe. In a cruel twist of irony, the very expansion that isolates us from the rest of the cosmos might be the only thing that saves a distant part of the universe from our local collapse. Is it a nothingness or a newness? We call it the bubble of nothingness because, to us, it represents the total erasure of our reality. But from the perspective of physics, It is a phase transition. When water freezes into ice, the liquid reality of the water is destroyed. To a microscopic organism that can only survive in liquid water, the ice is a bubble of nothingness. It is a hard, cold, uninhabitable void. But to the universe, the ice is simply a more stable, lower energy state of matter. The true vacuum inside the bubble might be capable of supporting an entirely new kind of complexity. Perhaps different forces emerge, forces we cannot name and cannot imagine. Perhaps atoms of a different sort form, creating stars that emit a different kind of radiation. But for us, the creatures of the false vacuum, the transition is final. We are the liquid inhabitants of a universe that is destined to freeze. The bubble of nothingness is the cosmic reset button. It is the moment the universe decides that the 13.8 billion year experiment of baryonic matter, atoms, stars, and people, has reached its conclusion. The ultimate conclusion of Chapter 3. The bubble of nothingness teaches us that reality is a privilege, not a right. We exist in a pocket of space that is currently formatted for our existence, but that format is not right protected. As the bubble expands, it carries with it the ultimate truth of the vacuum decay paradox. The universe does not care about our complexity. It does not care about our history. It is simply a system seeking its lowest energy state. And once it finds that state, it will sweep away everything we have ever known in a silent, invisible, and instantaneous microsecond. In the previous chapters, we visualized the physics of the collapse, the false floor of the Higgs Field, and the bubble that consumes the stars. But to truly grasp the horror of the vacuum decay paradox, one must move away from the how and focus on the when. Specifically, the terrifying realization that the end of the universe is not a future event we can prepare for, but a silent executioner that could be standing directly behind us at this very moment. In traditional cosmology, the end is usually something far off and predictable. We speak of the heat death of the universe occurring in trillions upon trillions of years, or the sun expanding to swallow the earth in 5 billion years. These are deaths we can see coming. They are rhythmic, mathematical, and patient. Vacuum decay is different. It is the only cataclysm that is physically impossible to detect before it arrives. It is the ultimate cosmic ambush, the causality trap. To understand why vacuum decay is the silent executioner, we must look at the fundamental speed limit of our reality, the speed of light, c$. In our universe, c is not just how fast photons travel. It is the speed of causality. No piece of information, no physical force, and no warning signal can move faster than light. When a vacuum decay bubble nucleates, the energy of the transition pushes the wall of the bubble outward at exactly the speed of light. This creates a causality trap. Imagine a massive explosion occurring on the surface of the sun. It takes 8 minutes for the light from that explosion to reach Earth. For those 8 minutes, we are blissfully unaware of the catastrophe. However, because the explosion's debris and radiation move slower than light, we would see the flash before the physical impact hit us. We would have a narrow window of awareness. With vacuum decay, the flash and the impact are the same thing. The information that the universe has ended travels at the exact same speed as the end itself. The wall of the bubble is the event horizon of our destruction. By the time the first photon of the transition reaches your eye, The wall has already reached your atoms. You cannot see the executioner's blade because the light required to see the blade is being consumed by the blade itself. The illusion of the present. This brings us to a haunting philosophical realization. We have no way of knowing if the universe still exists 5 light years away. When we look at Alpha Centauri, we are seeing it as it was over 4 years ago. If a vacuum decay bubble nucleated there 3 years ago, the real Alpha Centauri has already been deleted. It is gone. The stars have been extinguished, and the laws of physics there have already collapsed. But because the news of that collapse can only travel at the speed of light, we still see the stars shining brightly in our night sky. We are living in a ghost universe. We are looking at a sky filled with potential corpses. The silent executioner could have already claimed half of the Milky Way, and we would continue to go to work, fall in love, and plan for the future, totally unaware that the light-speed wall of non-existence is just hours away from our solar system. The Microsecond paradox. The silent executioner also redefines our relationship with time. In a standard disaster, there is a sequence: cause, then effect. In vacuum decay, for the victim, the cause and effect are simultaneous. Physicists call this the microsecond paradox. Because the transition occurs at the speed of light, it bypasses the biological hardware of the human experience. Your brain requires a specific amount of time to process a stimulus, roughly 13 milliseconds for visual information, and even longer to form a conscious thought. Vacuum decay happens in a microsecond. If the wall passes through you, you do not die in the traditional sense of a heart stopping or a brain losing oxygen. Instead, the very concept of you is deleted from the source code of reality before your nerves can even send a pain signal to your brain. It is the only death that is truly instantaneous. You are here, and then, without a transitionary moment of fear or awareness, you are simply not. There is a strange, dark comfort in this. To be killed by the silent executioner is to never know you were at war. It is a transition so perfect that it leaves no one behind to mourn. The mathematical shadow. Are we already in the path? If the universe is truly infinite, then the probability of a vacuum decay event occurring somewhere becomes 100%. Somewhere, in the unfathomable reaches of the unobservable universe, a bubble has almost certainly started. This leads to the dark forest of probability. Since we cannot see the bubbles coming, and since we know they are statistically likely to exist in an infinite space, we must accept that we are constantly in a state of pre-deletion. Some theorists suggest that the only reason we haven't been hit yet is because of the expansion of the universe. Space is stretching. If a bubble starts in a galaxy that is receding from us faster than the speed of light, due to the expansion of space-time, that bubble will never reach us. The executioner is running, but the floor is stretching away faster than he can sprint. However, if a bubble nucleates within our local group of galaxies, there is nothing to stop it. We are effectively sitting in a darkened room, knowing there is a bullet in the air, but unable to hear the gunshot or see the flash. We are just waiting for the moment the now becomes never. The psychological weight of the executioner. Why does this theory terrify us more than the heat death of the universe? The heat death is inevitable, but it is polite. It gives us time to evolve, to leave the planet, to build a legacy. It is a slow fade to black at the end of a long movie. The silent executioner is a jump scare. It robs us of the narrative of our lives. It suggests that at any point, mid-sentence, mid-breath, the story could simply stop. Not because of a mistake we made, and not because of a predictable cycle of nature, but because of a quantum fluke in a field we can't even see. It turns the vacuum of space from a passive backdrop into a predatory entity. Every cubic centimeter of empty space becomes a potential source of total annihilation. We are walking on a minefield where the mines are invisible and the explosion moves at the speed of thought. The conclusion of the silent executioner. Chapter 4 leaves us with a shift in perspective. We usually think of safety as the absence of visible threats. If there are no asteroids on a collision course and no nearby stars going supernova, we feel secure. But the vacuum decay paradox teaches us that the greatest threat is the one that cannot be seen. The silent executioner is built into the very fabric of the room you're sitting in. It is the 0 point of the air you breathe. As you finish reading these words, the universe continues to exist. But the paradox remains. The only reason we know the universe survived the last second is because we are still here to observe it. We have no guarantee for the next microsecond. The executioner is always there, blade raised, moving at the speed of light, silent and certain. We have spent the last 3 chapters exploring the anatomy of a cosmic catastrophe. We have looked at the false floor of the Higgs Field, the tunneling trigger that could crack it, and the silent executioner of the light-speed bubble that would erase us. By all accounts, the universe should be a graveyard, or rather, it should never have existed long enough for us to ask these questions. This brings us to the most confounding part of the vacuum decay paradox, the impossible stability. If the universe is as fragile as the math suggests, why has it lasted for 13.8 billion years? Why didn't it collapse in the first nanosecond of the Big Bang? We are living in a reality that, on paper, looks like a coin that has been flipped 10 trillion times and has landed on heads every single time. In this chapter, we explore the cosmic braces that might be holding our reality together and the razor-thin margin between existence and evaporation. The razor's edge, the Higgs top quark connection. The stability of our vacuum depends on a very specific relationship between 2 particles, the Higgs boson and the top quark. Think of these 2 as the opposing weights on a scale. The mass of the Higgs boson determines the strength of the Higgs field, while the top quark, the heaviest known elementary particle, acts as a sort of destabilizer. Through a complex quantum process known as renormalization, the top quark essentially pulls the energy of the vacuum downward. When physicists at the Large Hadron Collider, LHC, finally measured the masses of both, they found something chilling. The universe sits almost exactly on the triple point of stability. If the top quark were just a few percent heavier, the vacuum would be fundamentally unstable, and the universe would have collapsed immediately after its birth. If the Higgs boson were just a few percent lighter, we would be in the same situation. Instead, we are in the metastable zone. We are in a state that is technically doomed, but has an incredibly long expiration date. It is as if we are a car driving along a cliffside. We aren't falling yet, but we are only inches away from the drop-off. The impossible stability refers to the fact that we are balanced on a razor's edge, yet we have remained there for billions of years. The early universe hurdle. Why didn't we pop? The mystery deepens when we look back at the Big Bang. In the earliest moments of the universe, the inflationary epoch, the energy levels were billions of times higher than they are today. During this period, the jittering of quantum fields was violent and extreme. If the Higgs field is susceptible to tunneling now, it was 1,000 times more vulnerable during the birth of the cosmos. High temperatures and high energies generally make phase transitions easier. It's like shaking a tray of marbles. The more you shake it, the more likely a marble is to hop out of its current slot and find a lower one. Many cosmological models suggest that the Higgs field should have tripped during inflation. The fact that it didn't, the fact that our false vacuum survived the most turbulent era of cosmic history, suggests one of two things. Either we are incredibly lucky, or our understanding of the Higgs field is incomplete. The unknown braces. New physics to the rescue. To explain this impossible stability, many physicists believe there must be new physics acting as a brace for the vacuum. We are currently looking at the universe through the lens of the Standard Model, which is our best map of the subatomic world. But the Standard Model is notoriously incomplete. It doesn't explain dark matter, dark energy, or gravity. It is possible that there are undiscovered particles or forces that stiffen the Higgs field, making it much harder to tunnel than our current math suggests. Supersymmetry, SUSY. This theory proposes that every particle has a superpartner. If SUSY is real, these extra particles would provide a counterbalance to the top quark's destabilizing effect. They would effectively level out the energy landscape, turning our precarious ledge into a much wider, safer plateau. Dark matter coupling. Some theorists suggest that the Higgs field might be linked to the dark matter that makes up 85% of the universe's mass. This connection could act as a stabilizer, pinning the Higgs field in its current state and preventing it from tunneling. Gravity as a stabilizer. At extremely high energies, gravity might change the way quantum tunneling works. It's possible that space-time itself resists the formation of a true vacuum bubble, acting like a cosmic tension that keeps the false floor from breaking. The anthropic shadow. We are here because we are here. There is another, more philosophical explanation for our stability, known as the anthropic principle. This theory suggests that we shouldn't be surprised to find ourselves in a stable enough universe, because if the universe were unstable, we wouldn't exist to observe it. In a multiverse scenario, there could be trillions of other universes that did collapse in their first microsecond. Those universes are dark, empty, or non-existent. We are the survivors of a cosmic lottery. We live in one of the few lucky patches of the multiverse where the Higgs field happened to get stuck on a ledge that lasts for at least 14 billion years. To us, the stability seems impossible. But that's only because we are the only ones left to talk about it. The primordial black hole problem. Recent studies have added a new wrinkle to the stability mystery. Primordial black holes, PBHS. These are tiny black holes that may have formed in the first seconds after the Big Bang. According to some calculations, the presence of even a single tiny black hole would act like a seed for vacuum decay. Black holes curve space-time so severely that they could theoretically catalyze the tunneling process. If PBHS exist, they should have acted as the sugar cube in the superheated water, triggering the collapse billions of years ago. The fact that we are still here suggests either that primordial black holes don't exist, or, more tantalizingly, that the vacuum is much more resilient than our current quantum field theories allow. This resilience is the holy grail of modern physics. If we can understand why the vacuum hasn't collapsed, we may unlock the secrets of the unified field theory, the comfort of complexity. In the end, the impossible stability tells us that the universe is robustly fragile. It is like a cathedral built with such precision that a single misaligned stone could bring it down. Yet it has stood through centuries of storms. When we look at the stars, we aren't just looking at light. We are looking at the triumph of stability over chaos. Every second that the universe continues to exist is a victory against the laws of probability. The Higgs field remains on its ledge. The top quark remains in check. The silent executioner remains in the shadows. We are supported by braces we cannot see and laws we are only beginning to write. But as we move into the final chapter, we must ask, if the floor eventually does give way, is it truly the end of everything? Or is the impossible stability just a prelude to something even more complex? The final realization of Chapter 5. The stability of our world is not a given. It is a miracle of mathematical balancing. We live in the Goldilocks zone of quantum physics, not too stable to be boring, and not too unstable to be impossible. We have survived the Big Bang, the era of inflation, and billions of years of cosmic evolution. But the paradox remains. The impossible stability is only impossible if our current map of the universe is the only map. In the final chapter, we will look beyond the collapse to see if the end is actually a reset. We have spent this journey standing at the edge of the abyss, peering into a void that could swallow us in a microsecond. We have mourned the loss of the stars, the dissolution of our atoms, and the erasure of our history. But in the final chapter of the Vacuum Decay Paradox, we must confront a startling possibility. What if the collapse of our vacuum isn't a death sentence for the cosmos itself? What if it is merely a reformatting? In computer science, when a system becomes too cluttered, fragmented, or riddled with errors, the only solution is a hard reset. You wipe the drive and reinstall the operating system. To the files on that drive, the reset is total annihilation. But to the computer, it is a fresh start, a return to a state of high potential and perfect order. Beyond the wall of the expanding true vacuum bubble, the universe doesn't stop existing. It changes. And in that change, we may find the most profound secret of our existence, that we are not the protagonists of the cosmic story, but perhaps just one draft in a never-ending series of revisions. The birth of a new physics when the Higgs field finally settles into the true vacuum state. It releases a staggering amount of potential energy that has been stored in the fabric of space for billions of years. This isn't just a change in mass. It is a phase transition more violent than anything since the Big Bang. Inside the bubble, the operating system of the universe is rewritten. The fundamental constants, the numbers that determine the strength of gravity, the speed of light, and the charge of an electron, are recalculated. In our current vacuum, the laws of physics are fine-tuned for the existence of atoms. But in the true vacuum, The new laws might be tuned for something entirely different. Perhaps gravity becomes a repulsive force, causing space to expand with such ferocity that galaxies can never form. Or perhaps the strong nuclear force becomes so dominant that the entire universe collapses into a single, massive crystal of subatomic particles. However, there is a more tantalizing possibility. The true vacuum might be more complex than our own. Just as the cooling of the early universe allowed for the formation of protons and neutrons, the cooling into the true vacuum might allow for the emergence of supermatter, particles and forces that are currently invisible to us because our false physics cannot sustain them. The second Big Bang. Many physicists, including those exploring the cyclic universe theory, suggest that vacuum decay might be the mechanism for a second Big Bang. As the bubble expands at the speed of light, it incinerates everything in its path, converting the matter and energy of our old universe into raw, high-density radiation. Within the bubble, the temperature reaches trillions of degrees. This is essentially the primordial soup all over again. Inside this new, true environment, the universe might undergo a new period of inflation. The energy released by the Higgs transition could act as the fuel for a new era of cosmic expansion. In this scenario, we aren't looking at the end of the world. We're looking at the birth of a successor universe. This new universe would be born from the ashes of ours, using the same space, but different rules. It would be a reality where the stars are made of different elements, and the life that eventually emerges, if it does, would look at their own sky and wonder about their origins, never knowing that their entire reality was built on the graveyard of a false vacuum that preceded them. The information paradox. Does anything survive? The most haunting question of the reset is whether anything of us remains. In physics, there is a principle called information conservation. It suggests that information about the state of particles can never be truly destroyed, only scrambled. If you burn a book, the information in the book isn't gone from the universe. It is technically hidden in the smoke, the ash, and the heat. If you had a powerful enough computer, you could theoretically reconstruct the book from those remnants. Does vacuum decay preserve our information? As the wall of the bubble passes through you, your atoms are ripped apart. Your DNA, your memories, and your physical form are converted into raw energy. However, that energy is still there. It is incorporated into the wall of the bubble. In a sense, the expanding shell of the true vacuum is a record of everything it has consumed. It carries the energy signature of every star, every planet, and every person it has erased. We would become a frequency in the new universe's background radiation. We would be the static on the radio of a civilization that hasn't been born yet. The multiverse of bubbles. If vacuum decay is possible, it implies that the universe is a multi-phase entity. Instead of one single, uniform reality, we might live in a cosmic foam. Imagine a vast ocean of false vacuum. Within this ocean, bubbles are constantly popping into existence. Each bubble is a true vacuum relative to the space around it, and each one possesses its own unique set of physical laws. In this everlasting inflation model, the reset is happening somewhere right now. While you are reading this, a universe is ending, and a new one is beginning. This turns the vacuum decay paradox from a tragedy into a reproductive cycle. The universe reproduces by collapsing into lower energy states, creating new environments for complexity to emerge. We are just one bubble in a foam that stretches toward infinity. Our floor might be false, but it is the temporary platform upon which the infinite drama of the multiverse is played out. The final existential twist. Are we already the result of a reset? As we conclude this exploration, we must face the ultimate acronium twist. If the universe is 13.8 billion years old and vacuum decay is a natural part of cosmic evolution, what are the odds that we are the first version of reality? There is a theory that the Big Bang itself was actually a vacuum decay event from a previous higher energy state. We think we are in a false vacuum now, but perhaps the empty space of the era before the Big Bang was even more unstable. Our Big Bang might have been the moment, a bubble of somethingness nucleated in a void of nothingness. We might be living in version 2.0 or version 10,000 of reality. The laws of physics that we find so perfect for life, the way gravity works, the way light travels, might be the optimized settings left behind by a previous collapse. In this light, the paradox isn't scary. It is a sign of a universe that is alive, a universe that experiments, fails, resets, and tries again. Conclusion. The comfort of the cosmos, the vacuum decay paradox takes everything from us, our permanence, our safety, and our future. But in return, it gives us a perspective that is truly cosmic. It teaches us that we are part of a grand energetic process. We are the ripples in a field that is billions of light years wide. Whether the reset happens tomorrow or in 1 trillion years, the story of the universe will continue. The energy that makes up your heart and your mind cannot be destroyed. It can only be translated into a new language. We are the inhabitants of the false floor, the children of the ledge. And while the executioner may be silent and the end may be instantaneous, we are here now. In the microsecond before the reset, we have the unique, impossible opportunity to look at the stars and understand the rules of the game, even as they are being rewritten.